In our previous classes, we have seen OOPS concepts, encapsulation, inheritance, and abstraction. Let us see polymorphism today. Polymorphism is the ability of an object to take different forms depending upon the context. Polymorphism enables you to treat objects of the subclasses as objects of the superclass or base class. To understand this, let us take simple example. Imagine we are building an application to manage pets. At first, we have only dogs. We have dog class, which has simple behavior, make sound. At first, we have only dog, so let us make dog array to keep track of pets. This program works, but it can only keep track of dogs. Suppose we want to extend this pets application to include cats also, but this code doesn't work with cat objects. We could solve this in two ways. Create a separate cat array which duplicates the code and becomes hard to manage, and create combined class for cats and dogs, and create two arrays, cats and dogs as instance variables, and add cats and dogs. But the two arrays cats and dogs require separate methods and become complex quickly. Both approaches are not scalable. By using the polymorphism, we can solve this problem very easily. To support multiple types of animals without duplicate code, we can use polymorphism. To achieve the polymorphism, we need superclass. Here, let us first create animal superclass. This superclass will have behavior, make sound, but we are not sure which sound animal can make until unless we know the exact type of that animal. So let us make it abstract. This animal class has an abstract method, so we need to declare this class abstract. This dog can extend the abstract class animal. Now this dog class is giving the implementation for this abstract method make sound. Dog will make sound of. Similarly, we can create the cat class which will also extend the animal class. Instead of this dog array, we can create the array of type animal. This is array to hold the animal objects. This is just array of objects of type animal. We are not creating any instances of the animal. Since it is abstract class, just we are creating array of type animal. This array animals of type animal can hold both dogs and cats. Animals of 0, we can place dog object. Similarly, animals of 1, we can place another dog. We can even place cat. Both cat and dog can make sound, but can make different sounds. Let us call that make sound method on all the animals. From this collection or array, if we run this code, it will print first two objects are of type dog, so it will print woof. Then we have cat object, so this make sound method will print meow. This array is polymorphic. Here we are assigning the subtype object to this supertype reference. We can have polymorphic arguments and return types also. See here we have one static method, let's here, which is accepting the animal object. We are calling this let's here by using cat object, and we can also call this let's here by using dog object. In place of this supertype, we can substitute any of the subtype objects. This is polymorphic argument. Based on the object type, this make sound method will be called. If we pass the dog object, then make sound method in dog will be called. If we pass the cat object, make sound method in the cat will be called. This animals array is the polymorphic here, which can accept the subtype objects. Whenever we assign the subtype objects to supertype reference variable, then we can get the polymorphism. What is the benefit of this polymorphism? Using this polymorphism, we can extend this system easily. Suppose we decided to add other animals like lion, tiger. As long as they extend the animal class, they will work with this animals array without breaking our previous code. Using polymorphism through animal superclass offers several benefits. We can use this single array to manage different animal types, avoiding redundant classes or code. If someone else add new animal types, they don't need to change the existing code. They just need to create the new subclass of animal. With this polymorphism, we have created a system that grows with our needs without requiring significant code changes. This is the true advantage of polymorphism. It is scalable. Let us see the summary. An object of subclass can be used whenever its superclass object is used. This is commonly known as polymorphism. Polymorphism enables you to program in general rather than program in specific. With polymorphism, we can design and implement systems that are easily extensible, means we can add new animals with minimal code changes. New classes can be added with little or no modifications to the general portions of our program as long as the new classes are part of the inheritance hierarchy. So with polymorphism, we can write future-proof code. If we use the supertype reference to hold the subtype objects, we cannot access the methods which are only specific to that subtypes. Let's take simple example. Let's say we want to add method that applicable to only dog but not cat. We should add that method in dog subclass. Here we added this guard method. This guard method is specific to this dog, which cannot be applicable to cat. If we use supertype reference with polymorphism, we can assign the subtype object to supertype reference. With this supertype reference variable myDog, we cannot call guard method. Here object is of type dog, but still we cannot call this guard method on this supertype reference. We are getting this error. The method guard is undefined for type animal. Compiler decides whether you can call a method based on reference type, but not based on the actual type of the object. It will enhance the type safety. It prevents you from accidentally calling a method that might not exist in all subclasses of the superclass. If you want to call this guard method on supertype reference, we can use instanceof to check the actual type of that object, even if it is instance of dog, but this reference type is animal, so we need to cast this to dog type. Then it will work. This approach allows you to call subclass specific methods while keeping benefits of polymorphism, but we need to check the type explicitly by using this instance of operator.